Welcome back. This is Untitled Chassis. My name's Scott. Today's project is mounting this snowplow to this John Deere lawn tractor. Now these parts and pieces aren't necessarily meant to go together, or if they are, I don't have everything to make it work. So what we're going to do is we're going to adapt what we've got to make it work. So let me get you a little closer and show you what I've got planned. So what we've got going on here is we need to make a pivot for the blade to raise up and down. Now I think that this bracket was originally intended for this to be the pivot. But what we're gonna end up doing is we're gonna end up cutting this section off of both sides, and we're gonna bore a hole down here. We're gonna make the pivot here. Now, what we're gonna do on the tractor side is we're going to utilize this bolt hole and this notch to mount a piece of 3/8 plate on both sides. It'll be triangular shaped, and then we'll come out here like such, and we'll have a point here for the pivot. Now this upper mounting hole will have a bolt which will be the only fastener to attach the bracket. The bottom will have this bar welded so that the bracket will simply slide into that notch, be pivoted up, and this bolt hole will line up. So that may not be 100% clear, but the first step is to make a pattern for this bracket. So let me get a piece of cardboard and make a pattern up, and I'll be right back with you and show you what that looks like. All right, so here we are. This is the template all finished up. Now what I did was I just roughed out a piece of cardboard, and then I went ahead and punched a hole in it for that lower bar where it's going to fit into that notch, and then placed the cardboard over that, and then came in and traced from the back side where this upper bolt hole is going to be located, and then also from the back side traced the outline of the bracket that's already on the tractor. Now I transferred this line, which is basically a vertical line, to this side of the template, and then I measured from the floor up to the height that I want the pin, which is going to be the center of that bracket that the blade pivots on, and then measured that in two places, which created a horizontal line, which means that where this is where the pin for the blade pivot's going to be could be anywhere along this line, but I knew that I wanted it forward of this bracket. This line represents the front of that bracket on the tractor. So I moved this center line 1.5 inches forward of that line, and then this will be a piece of 3/4 inch bar that will be the pin. So there'll be a 3/4 inch hole here, and then transferred with a circle template a line outside this center point to correlate with the outside of the bracket, and then just connected the points on the outside to give me my perimeter of my bracket. So we'll have to cut 2 of these out. We'll probably rough them out with the plasma and then gang them together and do the drilling there. Now this upper hole, we're not going to drill this until we get this into position, and then what we can do is put a transfer punch in the upper hole, and then swing this up, and then create an arc on the back side, and then create another line along this so far off so that we can get this hole exactly where we want it. So let me get set up to go ahead and cut these out of some 3/8 scrap plate that I've got, and I'll get you right back and show you a little bit of that action. Okay, so here we are, all cut out. Now off camera, I went ahead and knocked the flash off of these and then ganged them together as close as possible, and then put them in the vise and took a flap wheel and leveled out these edges as best that I could, and then tack welded the pieces together. And then from there went to the belt sander and rounded all these edges. Now from there, what I did was go ahead and place the template on top with the best fit, and then center punch this hole for the pivot, and then this lower hole for the bar. And I know earlier I discussed that I was going to do this and mark it later. That plan has changed. I went ahead and center punched this one as well. So I'm off to the drill press. We're going to punch a 3/4 inch hole here, 1/2 inch hole here and here, and I'll bring you back and let you take a look at it after that. Okay, so here we are back on this. I've got these plates drilled out. This hole is going to be for that lower notch where the bar will go through. I ended up having to drill it out to 17/32. This bar is just a hair over 1/2 inch, so the 1/2 inch hole wouldn't allow this to pass. This is 1/2 inch. There will be 7/16 bolts in that top side. So from here, what we're going to do is we're going to go ahead and split these back apart, knock these tack welds off. We'll get these bolted to each side of that lower bracket. And what we'll do on one side is we'll take a washer and bolt it between that lower bracket and this. And we'll also do the same thing on the bottom where the bar goes through, and we'll clamp the bottom so that it's tight against the bracket. And we'll get this bar through there and we'll weld it around the outside. Now, what I've got in mind actually is that the finished product will have a strut that'll go from, if these brackets are side by side and this bar goes in between, that somewhere up here behind this pivot we'll run another piece of tube or something across to stiffen this whole assembly up. So, but that'll be one of the last things we do after we get the width adjusted up here. So let me get these tack welds ground off. We'll get this thing bolted up, and we'll get back underneath the tractor and let you see what that looks like before we get this welded up. Okay, so here we are all bolted up. Now we've got a washer behind this bracket on this side only, and that's to space this over. And the idea is that when we weld this, the weld's actually going to pull this even tighter. And so by putting a washer in there, then when we do the final assembly, those washers will be left out, and that'll allow this bracket to be slipped on much easier. What I've done is this lower rod, I've got it centered from side to side. I'll go ahead and get a couple tack welds on this, and the welds on this will be completed when we do the final welding on the rest of the project, but the tack welds will hold my width on these brackets. So let me go get that done, and we'll start working on the bracket for the blade. Okay, so here we are. This is the bracket that goes between the blade on this end and the tractor on this end. Now, there's going to be a bar, 3/4 inch bar, that goes right through here that the blade will pivot on, which is that forward hole in the bracket that we just mounted on the tractor. Now what I've done, because the width of this bracket is 3/4 of an inch narrower than the inside width of those two brackets we just built and put on the tractor, is I've got these spacers. These are just some leftover material, just some slugs out of some header flanges that I had cut out, and I saved these just for a moment like this. So these are made out of 3/8 just plain carbon steel. And what I've done is I've located a hole on both sides of this bracket in the same position, and then I took these two slugs and I ganged them together, and I found the center. Now, you know, this is not done to an accuracy of 10/1000ths of an inch or anything of that nature, but you know, it'll be good enough for this. And so what I'm going to do now is I've drilled a pilot hole in this bracket on both sides and on these slugs. So I'm going to take the same drill bit and I'm going to line those up. Then I'm going to clamp this down and I'm going to go ahead and weld these on. And then after I do that, I get both sides welded on, we'll go back and then we'll drill this hole out on both sides to 3/4 of an inch for that bar to pass through. And then we'll come back later and we'll cut this top tube off. Now before we do that though, I am going to put a tube on the inside to hold this stiff. And what we may do on that tube as well is we may actually put a grease fitting on it so that we can grease it from up front. And then the grease will go inside of that tube on the outside of this bar that goes through and then come out on both sides of this. There's a lot of better ways to do this. You know, we could use bronze bushings or something of that nature, but you know, this is a low budget deal, just something we're going to try and get done. This thing might get used once or twice a year, so it'll just be a steel bar running on, you know, these steel pieces here. So let me go ahead and get that done, get this welded on, get those holes drilled out, and I'll come back and let you take a look and see what that looks like. Okay, so here we are. Got those pieces welded on and got them drilled out. Now, as you can imagine, these had to be drilled from each side, and there was little to no chance that these were ever going to line up. In fact, with a 3/4 inch drill bit, there was little to no chance that this 3/4 inch bar was actually ever going to line up or actually go through the hole. So what I did was I used a adjustable hand reamer to open the holes up, and then once the holes were opened up, I could slip the tube in, and then I could see where it was, the hole was actually aimed. So like in the case of this hole, it was aimed like this. So I took the reamer and tried to cheat the hole so that I could get it to where it would line up. Now, you know, this is not high-tech machining here, but I mean, this is not something that, I mean, you know, the thing's never going to get a full revolution. You know, all it has to do is cycle back and forth. So I had to do that on both sides to get this bar to fit and meet both holes. And so the next step, I've already cut the tube, is we're going to put a tube around this. And this serves a couple of purposes. One is that it'll help stiffen this bottom of this bracket up. And in addition, I think what I'm going to do is I'm going to drill a little hole and I'm going to fabricate a little bung for a grease zerk, so that once this is on, you can shoot grease in here, and the grease will fill this tube up and come out and then squirt out through these bosses that we welded on. So I'm going to go ahead and get this thing centered up, get it on, get it welded, and we'll get back to the brackets on the front of the tractor and get the cross brace for them welded in. So when I get to that point, I'll bring it back, show this to you, and we'll start on that. Okay, so last time we worked on this, we were going to go ahead and get this bar welded on the outside and put this spreader bar in between these brackets. So we got all this done. We got all this welded, and so everything left now is everything left to do is to finish it. What we're going to do, we're going to put a grease fitting in here on this tube. That way we can shoot grease into this tube and along this shaft and out into, and it should come out in between between this boss and these brackets. Should provide enough lubrication for what we're doing here, and every time you use it, a couple squirts of grease will keep the thing going. So what I did, I took a piece of bar stock and I drilled it. Now I'd have been better off if I'd have been able to do this on a lathe, but my lathe is not functioning right now. So I simply stood this up in a drill press vise and just eyeballed the center. I mean, all we're looking to do is create a boss for a grease zerk to fit. And I think you can see that I did a real good job of missing the center. But I think I got it close enough to the center that we're going to be in good shape on this thing. So I drilled that thing out, tapped it for a, what is this, 1/8 inch pipe tap, 1/8 inch 27 pipe tap. And so this will provide us a place to put our grease zerk. And what I'll do now is I'll go and cut this off. and then we'll drill a hole in this tube, and then we'll take that piece and we'll put it on top of that tube directly over that hole. We'll TIG weld that around the outside. That will seal that off so that the grease will make its way into that inside that tube. Now, aside from that, the next thing will be to go ahead and create this shaft. What I'm going to do is I'm going to take this piece of tube. This is actually tube. It's not solid. It is tubing. And on one end, well, first we'll cut it to length. We'll get the right length. And on one end, I'm going to take a big fat washer and I'm going to weld it on the outside. And that'll create a stop. That way this thing will only go in from one direction. Then on the other end, we will go on the disc sander and put a bevel on this edge so that it will slip in as easy as possible. And then we'll drill a hole for a link pin. Is that what these are called? They're called finger smackers, if you ask me. It's your finger in the wrong spot. But anyway, we'll use this type of a pin. We'll go ahead and assemble this thing and slide it in. We'll mark the position for the hole, and then we will drill for it. That's what I'm going to do next, so that should be done by the next time I get back with you. And then from there, the only thing left is to create some type of a lever for which this blade can be raised and lowered. But I'll talk about that when we get to it. Let me go ahead and get this shaft made and get that grease zerk boss welded on. Okay, I wanted to bring you back for a second here before I went ahead and welded this washer on the end of this shaft. What I did to prep this shaft was squared it up on the disc sander and then took a countersink and chamfered this ID just to clean it up. I took a washer that was cadmium plated. Now, as you're probably aware, you can't weld through cadmium, and I don't like to grind it off. I think a lot of times, sometimes the grinding actually smears it into the surface. So one trick that I use is that I'll get a little container of muriatic acid, and then you can just drop your parts in there that have a little, a zinc or a cadmium plating on it. Now, you definitely don't want to breathe the stuff, but it cleans it all up. And so, this was a washer that was all yellow. I'm sure you've seen cadmium plated stuff, and it just takes it all off in a matter of minutes. Then you just pull your part out, rinse it off. And I did go ahead and prep the weld area just to condition that surface. And so what I'll do from here is just go ahead and place the washer on the end of the shaft and just eyeball center it, and then grab the TIG welder and go ahead and put a bead on the inside. And then that way, what that allows us to do, if we put a bead on the back side of this, when this shaft goes in, it wouldn't seat on that outside bracket, and we want to minimize that profile. I'll show you when we're done, but the tire actually comes pretty close to all this stuff, so that'll minimize how much sticks out from there. So, all right, let me get this welded up, and I'll get back with you and show you what it looks like. So here's the problem. What we want to do is we want to drill the hole for that pin in the end of this shaft. Now, if I had the vise set up on the milling machine, it wouldn't be a problem, but the vise isn't in, it's not trammed in. I don't want to take time to do all that. So, one trick is to use the slots in your table. They run the same, they're machined along with the center line of the ways. So what you can do is put the shaft in there, and if you can get centered up on that slot, then you're in good shape, and you'll be drilling right through the center of that shaft, of that round material. Now, what I would normally do, not the most accurate method, but good enough for what we're doing here, is I would use this type of a device to center up on that shaft. But the problem is that shaft being as small as it is and being that low, is that this piece won't go on it. So what we're going to do is we're going to use a piece of tubing, and this takes away a little bit from some of the accuracy. We're going to put that tubing on there, and then we'll mount this device in there and use it to center the spindle up with that slot, and then once that happens, then we can pull this out, and then we can put this back in here, and then we can drill, and we'll drill. That'll put us right in the center of that shaft. So hopefully that helps you out sometime. So let me get this done and I'll get right back with you. Okay, so all that's taken care of, and now we got to put together a way to lift this from the driver's seat. So what I've done is, this is an old scrap piece of what was originally meant to be a hoop for a dragster, and I've cut it up and squared up that end, and what we're going to do is we're going to weld it to the side of this plate, and then we're going to put an end on here to accept the chain. And what we'll do is we'll weld a plate that's at least this big and then leave some hang over, and we'll create a keyhole here for a chain to slip in. And that chain will run back to the handle that normally lifts the blade, and that handle then can be used to pull on this and raise and lower the blade. So hey, let me move the camera and show you what we're going to do on this end. This will be simply welded on like this, and I'll show you what we're gonna do up here. Okay. So what I've done is I created a pattern that matches the end of the tube. I scarf cut the end of this at 60 degrees, and that's so that when this plate gets welded on, that I won't have to bend it. If this was flat, that I'd have to bend this plate up that I put on the end of it. So we'll scarf this at 60, and then we're going to make that plate out of this piece of flat bar, some type of an accessory for a tractor, for something. We're going to take this clean end, and what I've done is transferred the outline of the tube to the end of the this flat bar, and then what we'll do from there is we'll cut the end of that off and go on the disc grinder and get rid of that, and then we'll come up here and we'll drill a hole. It'll be a 1/2 inch in diameter, and then we'll cut a slot with the milling machine and a roughing end mill like so that a chain can be slipped through this hole. In fact, here's the chain, and so this will then end up on the end of this bar, and you'll be able to then slip this chain through the large hole and then down in that notch, so that this assembly can be pulled this way from the driver's position. So let me go ahead and get this thing fabbed up and get it welded on here, and then we'll get this piece welded on to the piece that holds the blade, and the only thing that will be left will be the how to attach this chain to the driver's control. So let me get after this. I'll be right back. All right, so here we are all finished up. You can see here what I was talking about as far as the end of this lever, putting a keyhole. If we need to adjust the chain so that the low position of the blade is higher or lower, you can simply pull the chain out and let it go, and put it in a different length. The lever is in a position where when it's in the up position, it's out of the way of the tire and all that. And there's no sponginess or no flexibility in any of this, so everything's good and stiff. So let's take a look at the other end. Take a look at the clamp. So what I did on this end was I just took an 1.5 inch muffler clamp, like you could buy at the auto parts store. It was a little over $2, something of that nature. And this tube that's part of the lever, the original part of the tractor, was 1 inch in outside diameter. So I then took another short section of tubing and split it down the middle, and I welded half of it to the loop part and half to the base. And then what we've done is we've put a couple wraps of rubber, looks like maybe 1/16 or 3/32 of an inch of rubber, wrapped it around this first so that this doesn't get scratched up, the original paint doesn't get scratched up. And If necessary, this can be adjusted up or down, which will affect two things. This handle is spring loaded. If you move this down, it will help put more force to pull the blade up, but it will move it a shorter distance. Whereas if you move it up here, it's going to move the blade a longer distance, but the force will be less exerted on the chain. From there, what we did was take a piece of 1/4-inch bar, just put a little bend in it, cut it off, and weld to that loop with the chain around it. And then we've got a piece of yellow hose so that if the chain gets over into the paint of the tractor, it's not going to hurt the tractor. Everything works really well. The tension that's in this from the factory is just about right where the lever's at, and I think the amount of stroke as far as moving the blade up and down is going to be good. You can see it almost takes, I mean it almost holds itself in either position. Of course, it locks up there. It really takes just very little force to move it, so that's going to be pretty nice, I think. So let me move you back, get you a wide view. So here's what it looks like. Hey, if you like the video, don't forget thumbs up, comment, subscribe, and I'll see you on the next project. Thanks for watching.